In this video, we are going to look at the sine, cos and tan of 30, 45 and 60 degrees. And we're going to work them out as exact values in surd form. Now, if you're studying maths at A level or GCSE higher level, you need to know this. So let's look at this top triangle here. It's a right-angled isosceles triangle, okay? And you can hopefully quickly work out that this must be 45 degrees in here. So I shall just label that angle. And you should also be able to work out the hypotenuse of this triangle, which comes from Pythagoras Theorem, the square root of 1 squared plus 1 squared, which is the square root of 2. And that's the exact length of the hypotenuse. Okay? And now, using the definitions of sine, cos and tan, you should be able to see that the sine of 45 is the opposite over the hypotenuse. So the sine of 45 degrees is the opposite, which is 1 over the hypotenuse, which is root 2. Okay, now 1 over root 2, if you rationalize the denominator by multiplying by root 2 over root 2, will give you root 2 over 2. Okay, which is another way of expressing it. And you should also be able to see that if that's the sine of 45, the cos of 45 is the same, because that's the adjacent over the hypotenuse, and the adjacent is also 1. So therefore, we can conclude that that's also the cosine of 45. So what about the tan of 45? Okay, well, the tan of 45 comes from the opposite over the adjacent. And both of those have a value of 1. So it's 1 over 1, okay, which of course is just simply 1. Another way of thinking of that is if you have a hill with a gradient of 1, that means that for every 1 you go along, you go up 1. In other words, you would make this angle of 45 degrees. So the tangent of 45 is 1. The sine and cosine of 45 are both 1 over root 2 or root 2 over 2. Okay, now in this second triangle I've drawn, we're going to look at the sine, cosine and tangent of 30 and 60. Now I want you to imagine this equilateral triangle of side length 2. And what we're going to do is we're going to cut it straight down the middle vertically, okay, to remove half of it, leaving us with that. Okay, and if we just now consider this right hand half of it, I'll just take out these bits we don't need. We can have our line vertically down there to sort of section off half the triangle down there, and we know that we have a right angle at the bottom, okay, in here, and we have an angle of 60 degrees in there, okay, and we also know that at the top, where we've halved the angle that was 60, we now have 30 degrees in here. Okay, so we've now got a right angle triangle with a hypotenuse of 2. We know that this bit along the bottom here must now be 1 because we cut it straight down the middle. But what about the height of this triangle, the vertical height? Well, we use Pythagoras Theorem, and we know that if we know the long side and one of the short sides, we square and subtract. So 2 squared minus 1 squared gives us 3, okay, and this therefore has a length of root 3, okay, which is about 1.7. Okay, so that's the height of the triangle. And now we can use the definitions of sine, cos and tan to find out exactly what the values of sine and cos and tan of 60 and 30 actually are. So let's start with 30 degrees. So the sine of 30, okay, the sine of 30 degrees is the opposite over the hypotenuse. Now that's 1 over 2, okay, which is a half. And if we take the sine of 60, the sine of 60 degrees, okay, so from the angle at the bottom, the opposite is now root 3, but the hypotenuse is still 2. So its sine 60 is root 3 over 2. Okay? Now, if we take the cosine of 60, okay, the cosine of 60, that also gives us the adjacent over the hypotenuse from the 60, which is 1 over 2. And I'm writing it there because I'm showing you that the cosine of 60 is the same as the sine of 30. And similarly, if you were to take the cosine of 30 degrees by going to the angle of 30, looking at the adjacent, which is root 3, and the hypotenuse, which is 2, you would get root 3 over 2. Okay, and that's showing you that the cosine of 30 is the same as the sine of 60. All right, so quite an interesting set of results there. But what about the tangent of 30 and the tangent of 60? Well, let's have a look at that. Now, the tangent of 30 degrees is the opposite over the adjacent. So if we go from the 30, the opposite is 1 and the adjacent is root 3. So it's 1 over root 3. Okay, or if you prefer, you can write that as root 3 over 3. Okay, and the tangent of 60 is actually the reciprocal of this, because if you go to the tangent of 60, you're going to be doing, this is now the opposite, and the adjacent is now the 1. So the opposite and adjacent have swapped places. So basically, the tan of 60, instead of being 1 over root 3, is root 3 over 1. And root 3 over 1 is just simply root 3. Okay, so not only should you learn those ratios and remember them, but you should know how to recreate them using these two special triangles, okay, as I've shown you here. Good, take care.